proprietary code.
He was saying something like the IBN 5100 was built before PCs were using BASIC, so it can read IBN's proprietary programming.
Hey gamers, today we're going to talk about the IBM or IBN 5100 from Steins. The IBM 5100 is a 16-bit PC from 1975. It came with a BASIC or APL interpreter, or both. Here's a quick story refresher. After hacking into CERN, Daru finds a program written in the fictional Z programming language, which they think holds the research data for a time travel project from the 1970s. Since this program won't run on a modern PC, they're searching for a 5100 to run it. The 5100 is a reference to John Teeter, who is also directly referenced in the show, a time traveler from 2036 who showed up in search of a 5100 to debug legacy computer programs. In the show, it's said that the 5100 is specifically useful because it comes from a time before BASIC. That said, like, BASIC was the first programming language, but things like Fortran, Lisp, COBOL, and loads of other programming languages existed before that. Let's talk a bit about the file that they found on CERN's network. So, the 5100 only had a tape drive, a cassette tape drive, which was used to save data or load applications. It used quarter-inch DC300 tapes, which could store 204 kilobytes of data. There are really two ways that you could back up a cassette tape. You could save it either as a .cas file, which is essentially a disk image of the cassette, or a WAV file. We know that it's not a WAV file because they opened it in a hex editor, and WAV files have a specific look with only binary data inside of them. So we can infer that it is a CAS file. A CAS file is basically a disk image of a cassette for storage, where each bit on the cassette is stored as a bit in the file. It includes the synchronization headers and bytes, as well as the start bits. It's intended as an archival format for cassettes, which is essentially what is stored on the network. I can't find any CAS files for the 5100 specifically, but they'd be identical to those used by the TRS-80 or other similar cassette-based PCs from the time. Here's an example of a Star Trek game for the TRS-80. The CAS file can be opened and have its source extracted. They're really not that far off from a text file. The naming of the language to Z would imply that it's compiled similar to C. In any case, this isn't that important. You'd just have a slightly harder time understanding the assembly or binary, whatever was encoded on the cassette, compared to an interpreted language like BASIC or APL. Interpreted languages have the benefit of being human-readable instructions the whole time, instead of being translated to machine code. You can see this in the extracted source from the Star Trek game. By analyzing this example file, we can understand what the application does without even running it. For example, I know that this program first clears the screen, asks you to enter your name, and then shows the title screen. Anyway, this is all to say that the information that they had just from the cassette backup was more than enough to determine the function of the actual program stored inside. They didn't need the 5100. With that out of the way, let's talk about the actual content of the backup. Once they get it up and running, the Z program seems to be the name of the application, as shown by the title bar. The actual data is something like a PDF or Word doc, with full-color images, titles, and tables. Needless to say, the CRT display of the 5100 would not have been able to reproduce color images, or an image of any recognizable resolution. For example, here is a picture converted to 64 by 16 characters, the resolution of the display. Additionally, Daru says that there's a JPEG file stored inside. I'm not sure how a JPEG was created in 1975, considering that the format wasn't standardized until 1992. You definitely could write a kind of markup language to create nice printouts that looked similar to what they show on screen, but the 5100 would not have been able to render these high-quality images on its display. Anyway, there's nothing a 5100 or similarly old computer can do that a modern PC wouldn't be able to replicate. Even reading a proprietary programming language specifically created for the encoding of vintage Word docs storing time travel experiment data. It's a cool piece of science fiction, but any software written in the 1970s could easily be stepped through line by line to understand its operation. Anyway, thanks for watching. I know that the show is not trying to be perfectly realistic. Follow my YouTube, my Twitch, and my Twitter. Thanks.